Hello, today I'm going to show you in this video how to code time-based auton in vexcode Pro v5. So the first thing you want to cover in this video is what a function is. So basically a function is a recipe, but each time that you, instead of having a predetermined, let's say the recipe's for cupcakes, that you don't have a predetermined amount that the recipe will yield of cupcakes. So let's say the recipe isn't going to yield 12 cupcakes. It's going to, you can change the value every single time that you want to make the cupcakes. You just say, I want this many cupcakes this time. So that's kind of how a function works, just that there's going to be more than one variable, such as not how many cupcakes you want, but distance and then also speed. Also, before you begin programming auton, I highly suggest, and I can't enforce this enough, make sure you have with your team a clear understanding of what you want to do in auton. That will make your life so much easier as a programmer, but as well as like what you want, also so that you don't have misconceptions within your teammates. Once you, like, if you attempt to pre-program at home or things like that. Okay. Now that we have that covered, the way you program a function, you don't want to begin anywhere within a loop. Meaning any void, pre-made by Vex, especially, because you cannot call it within other sections. So, I'm sorry, I'm coming down with a bit of a cold, so please excuse my voice. I just wanted to get this done because I know a lot of teams are having competitions up soon. So you want to do this probably right after initializing variables for your motors in the controller. So I usually, when I did time-based auton, I would do it right after initializing a controller. If you don't initialize through here because you don't have a need to, I would suggest right after competition because that is usually always in your program either way. So you need to call something called void. What this does is a void function is a function that returns nothing, meaning it's not going to return a value of 1. You don't really need to know what it does exactly because you will most likely not be coding something like that does return something, which is usually a task, but for now void is fine. And then we're going to try. Also, if you don't have your user control done, I wouldn't suggest continuing with auton. Finish your user control first because it will make a lot more sense because I will be referencing things from programming user control. So you're gonna call drive. The reason it's yellow is because drive is a function within vexcode Pro v5 API, which is like the library, like a big dictionary for the things that you can do with it. But because it has parameter variables, when you call it, it does know what you're referencing. So we're gonna go double distance, then int speed. Okay, so double distance is that when you call this, which you'll see a lot later, this will make a lot more sense, trust me. Double distance means how far, and then int means speed. I can only guarantee for everybody that speed will be the same thing because everyone's motor speeds are the same, unless you're using torque things, but you probably know what that means when you're using things like that. And then distance, can't really guarantee because distance is affected not only by your gear ratio, but also by the weight of your robot, where you're testing this. Like, don't go testing this on things like laminate flooring, especially because Vex, the Vex flooring is very different compared to floor, because your robot will probably travel a lot easier on limit. You won't need to go as much on that opposed to a anti-static foam mat. So be careful when you're coding things like this, because nothing will be exact ever, because time-based autonomous is very variable. Okay, time-based autonomous, it's not my number one choice, but it is quite a very good choice for beginners, because it is easier to code and because it is simpler to understand. Also, you don't have as many issues with things like sensors and other things like that. So you have your distance and your speed, which are your only things that are going to change. So you're going to call like a variable. So if you have a two motor drive, you only do this twice, and then rotate 4 negative distance. And the reason why is because your rotation units won't allow you to be forwards for some reason. I don't know what happened with the Vex here, but you just need to put it in reverse. So basically you have to put a negative distance in there in order to go for a positive, when you call it for positive, to become forwards or things like that. It's a little confusing, but not much we can do about it. Speed, which is what speed we're gonna go at, which is the variable we have in our parameters, and then velocity units, which is PCT as usual. And then at the end, you have to put false, which means don't wait for this statement to finish executing. Go on and just move on to the next executable statement. So I just go down 3. I like to use my little shortcut and then just paste everything. And then I change my variable names here. They're close enough so I can just copy paste. And then the only thing I'm going to change overall is removing this last false. So basically right now we have a function that if you called it and you put in values right there, they will make your robot move forward or backwards depending if you have a positive or negative value. Yeah, moving on. If you ever have an issue with your robot, maybe just try removing the negatives. That might help it. But yeah, usually if you're having issues like that, usually just removing a negative or adding a negative will help it. I cannot guarantee for every robot because every robot is built differently. So just take things like that into consideration. So now we're going to have one for when you turn. So I like to make separate ones. Just helps me when I'm looking at my code. So when you're turning right, typically your left side will go forwards and your right side will go backwards. So what I'm going to do is just remove the negatives from there, and then I can do the exact same thing for when I do turn left. So instead of removing them for the right ones, I'm going to remove them for the left ones. And then for something like a lift, once again, the literal same code can work for almost anything. Lift, and then I put f at the end because lift is already a variable. Typically for people who have a 1 meter lift, just makes it easier. The thing doesn't get as confused. It's less likely to get confused. And then I delete the bottom 2. and then make sure to delete the false within it because we don't want our thing to have problems or our issues like that. And then we change our left lift, if I can spell. I'm not gonna bother spelling anymore. Okay, yeah. That's how you would do it. And then of course a negative value would make it go backwards, so sometimes I add little notes like this to help me remember things like this. For certain ones that do apply to this, I'll just add them. So like my drive and then my lift do apply like that. Now for a thing like a claw does give me an error because claw is most definitely already a variable. I'll just remove this bottom one, and then of course the false, because if it's the last string in the function, it doesn't need it. And then I just change the variable name that it's going to be executed. Okay, so right now we have basically all of our basic things for things like this. And then for things like, oh, I want to turn and go laterally, so basically only forwards or backwards. I mean, not turn. I want to go laterally and then also lift at the same time. Things like that. That is definitely possible. I forgot to call it void. So you would do something like this, and then you would put your parameter variables, just that these are going to be a little different. So you want a variable for your drive distance, and then one for your lift distance, as well as individual speeds for each of those. So drive distance, and then int drive speed, and then double lift distance, and then int lift speed. Now, for you would do something like this, and then at the end you would add this. So first thing, before I forget, you want to add a false there because you want it to continue. You want it to lift while you're driving. So yeah, and then you would add this instead here for your driving. Bam, bam, bam. And then this variable would go here, 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 here. And then this would go here and here. And then this would go here and here. Maybe you want to add a little spacing just to give yourself a little bit easier understanding of what's going on. So I'll just do that really quick. Especially since there's two things going on now. And also, you can do this technically for any combination. You can go drive and claw, lift and claw, drive and lift. Depends what you have on your robot. This is just the easiest way to do it. Then you would go down into where it says autonomous, like this. And the way you would call it is literally just go, let's say I want to drive forward. Just like that. So I recommend starting off with very small variables because trust me, they will go farther than you expect. You will be shocked at this. Because remember, your first thing that you're going to put within your parentheses when calling it is going to be your distance, and then this is your speed. Once again, this is going to be very different for each individual robot, so I cannot guarantee that one will go a certain distance for everyone's robot. Also, taking into consideration weight, autonomous time-based is going to be tedious. I will not lie, but it is a lot simpler than a lot of other types of autonomous programming because they involve a lot of complex math that even for me it's very difficult, as well as things like sensors and I believe they're called gyroscopes to detect how far a certain thing has rotated, things like that. So let's say I'm just gonna make myself a little list here. So this is how you declare like a comment that goes multiple lines, like this. So 1, I want to drive forwards. 2, I want to turn right. And then 3, open claw. 4, drive and lift simultaneously because I have 2 things there. And then 5, close claw. Yeah. So this is what I want to do during my autonomous. So right now I have drive forwards, then turn right. I'm just gonna put 1.75, and then at a speed of 90, and then open claw. So claw 1095. Oh yeah, okay. So my function name was claw F because claw was already something else. So remember that. And since we have 4 variables, our first variable was our drive distance. So I want to go 1.2 at a speed of 95, and then our second 2 were for our lift. So I want to go 0.6 at a speed of 90. And this is why negative value, because it will go in reverse. So I'm not sure if a negative value will open or close. You're just gonna need a test, and if it's wrong, well then you just flip the negative signs when you're doing here. And once you figure that out and it can confirm, I would suggest putting positive, like you can confirm, writing this statement here. These statements, because once you can confirm, it's just easier. And this is a very good example of why you plan out your autonomous beforehand, because as you can see, I use a combination of 4 functions, and I have about like 8 here. I'm not exactly sure. I didn't really count. But yeah, that's why it's pretty important to plan things out like this beforehand, because it will make your life a whole lot easier. Feel free to reach out to me if you have any questions on how to do anything here. But yeah, that's it for this video. I hope this helps you code your 10-based autonomous. Yeah. Also, last thing is, if you're coding your thing on a Google Doc, make sure you copy and paste that there so you can make sure you have all of your stuff saved. Trust me, I've forgotten way too many times. And yeah, hope this helps.